Well, welcome. Welcome to the research stage. I'm Christine Foster, and I'm with the Alan Turing Institute, and I wanted to give you a little introduction of what the Turing's about before we get into a big, meaty program of research. So the Turing is named after Alan Turing the man and built on the strong scientific legacy that he left. I think we famously know about his work, his more philosophical work around whether machines can think. And also that film, The Imitation Game, went a long way to telling everybody how much he did that was truly practical, that he woke up every day during the war and set up this bomb machine to figure out what the other side, what the encryption for the day was for the other side. And when they changed their tactics, he kept going, he kept moving, and all that. One part of The Imitation Game that doesn't do him justice is actually what a collaborator he was and how he worked across boundaries, across disciplines. And his last research paper was in fact in chemistry. It's a long way away from mathematics and computing. And it's a paper on morphogenesis, which describes how when two chemicals interact with each other, they actually interrupt each other in fairly predictable patterns. And there's in fact, and gives a decent explanation for how the tiger gets its stripes or how the leopard gets its spots. The hormones in the skin interacting with each other in a predictable pattern actually makes those stripes and those spots. And recently there was a paper that built off of his work that showed that creating synthetic versions of these Turing structures are actually quite good for taking salt out of water. So in fact, one of his last legacies might be that he may have given us the key to desalination. So philosophical, practical, and collaborative. And so the Turing Institute is really set up in that image. And we have our goals around fundamental research, some of which you'll see here today. We also work closely with industry and government and charities to apply that research to the real world use cases. We take a leading role in training up the next generation of data scientists and data science leaders, as well as helping leaders understand what it takes to have these kinds of skills and these kinds of technologies in their businesses. And then, of course, we're advising policymakers on responsible uses of the use of AI, of data, shaping the conversation, and we hope really being the voice of reason in this progress and this adoption of this technology. We've organized ourselves around 8 major challenges for the economy and for society. You'll see them written up here. I won't go through all of them in detail, but you will, as you spend time with us and see the research, you'll see the applicability in these various areas. So you'll have, we have a strong program around revolutionizing healthcare, everything from diagnostics, imaging, right through to queues and waiting times in A&E. We've also got a program around safer and smarter engineering. So rather than traditional engineering methods that would have had estimates of how materials would perform in the real world, now with cheap sensor technology and machine learning, it's much easier to get an actual read on what's happening to a structure. We've got all sorts of interesting use cases like that. Welcome. We're growing our partnerships with universities across the UK. We had started with 5, and we've added 8 more. And again, today you'll see representation from many researchers across our network. I'll make sure to highlight those as we go along. We're very excited to have that. Oh, I guess this is for our international audience, knowing that we're not just a kind of a London-centric institute. Despite us being located in the British Library, we've got universities across the country. And this point about strategic partners and partners of all kinds. So the top ones you see across there are our biggest partners who work with us on multi-year research programs, collaborative research programs, translational efforts. Lloyd's Register Foundation has been working with us for the last 2 years on safer, smarter engineering. Intel is very interested in understanding the relationships between the software and the hardware, so understanding the algorithms of the future to know what kind of hardware to build in the future. We have a strong partnership with GCHQ and a number of other departments on security and managing safety in a non-secure world, a less secure world, an insecure world. And HSBC is really about understanding the economy better, so moving away from traditional kind of pen and paper economics, with estimates and sampled national level statistics to the kinds of transactional data sets that commercial businesses have. And so they've, in addition to funding, they also provide the transactional data set so that we can understand, for instance, trade flows within a country, within regions, between cities, as opposed to just internationally, and real-time estimates of GDP, as opposed to kind of waiting every quarter for the kind of government versions to come out. And a whole array of projects with some of those other businesses below. And we also have the academic community, the research community, working together to come up with their interest groups, and really kind of bottoms up saying these are all the areas that we'd like to participate in, that we'd like to have conversations around. We convene across that. And we run week-long hackathons, these kind of data study groups that allow us to bring in problems from industry, researchers, data sets, and put it all together. And so really, I don't think you can see that. Let's do this one. So really, the underpinning all of this is the science, so around computing, around mathematics, around security, privacy, all of those together, and statistics and ethics and philosophy and machine learning, putting it all together is really what's underpinning our ability to meet those challenges, to drive research in those key areas.